This week we are going to be talking about loops. So there are three types of loops that we have in Java. One is called a while loop, one is a do while loop, and the third is a for loop. And I'm going to discuss each of those separately. So first, the while loop. A while loop looks a lot like an if statement. In an if statement, we say if, and we have a test, which is a condition. So it's either true or false. And if it's true, then we perform whatever code is within the brackets will get executed. Well, a while loop looks the same. You have the word while, and then you have a conditional test. And notice there is no semicolon at the end of that line, the same as we don't have a semicolon at the end of the if here. And if that condition is true, we're going to do whatever code, we're going to execute whatever code is within the brackets. The thing that's different about an if statement and a while loop is that an if statement happens exactly once. If it's true, we execute this code, we move on. If it's false, we don't execute the code, we move on. A while is a loop. And what happens is, as long as this condition is true, we will execute the code. So something that you have to do within your while loop is you have to provide a way for the condition to eventually become false. Otherwise, you have what's called an infinite loop. So here's an example of drawing circles on a screen with x increasing by 5. So you're going to draw circles all the way across the screen with your x moving over by 5 until you hit 100, which is the edge of the screen. So we're going to start x at 2.5, and then in the if statement, you would say if x is less than 100, we're going to draw the circle at x, which is the first time through, it's 2.5, 50, and then make the circle size 4. And then we are going to increase the x by 5. But this isn't going to work in an if statement because it's only going to happen once. Yes, x is less than 100 the first time through. We execute this code, and then we go out of the code. So if we want to draw a whole bunch of circles across the screen, we use a while loop. So the same way, we set x to 2.5. We're going to say while x is less than 100, we're going to draw the circle and we're going to increment x. So what happens is the code comes here, it looks at the x. Is x less than 100? Well, currently x is 2.5, so that's true. So we're going to draw the circle at 2.5, 50, size 4. And then we're going to increase x by 5. So x now becomes 7.5. What happens to the flow of control is we go back up here and test the condition. So now x is 7.5. Is that less than 100? Yes. So we're going to execute this code. X is 7.5, y is 50, the size is 4. We're going to increase x by 5. X now becomes 12.5. We come back up here and check the condition. This will be repeated until eventually x is going to be either equal to or greater than 100. Once that happens, this becomes false and we drop out of the code, we drop out of the loop. So as long as the condition is true, we keep executing the code that's inside of the loop. So here's some more examples of while loops. Okay, we can count. So these are called count controlled loops. When you do the counting, when you kind of increment your value by a certain amount, you're going to execute your loop a certain number of times, and it depends on that number increasing each time. So each time around. So we start here with I equal 1. While I is less than or equal to 10, we're going to print I. So the first time we print 1, then 2, then 3, because then we do I++, and we keep going around this loop till finally I is going to be 11, and this will be false. Now usually in computer science, we actually like to start counting from 0. So another way to write this loop would be to say I equals 0 while I is less than 10, and then you can print I or print I plus 1. So it all depends. Here we're counting from 1 to 10, so it makes sense to start the loop at 1. But a lot of times, remember in computer science, computer scientists really like to start counting from 0. And when we get into arrays, we're going to notice that most of our loops start at 0. Okay, and you have to make sure that your condition is correct. So if we're counting from 1 to 10 and we're starting at 1, then this needs to be less than or equal to. If we were starting at 0, then this would have to be less than 10, you see. So always make sure that you test your code and make sure that your condition is correct. Here is a loop that uses user input in order to decide when to stop the loop. This is called an event-controlled loop because once an event happens, that's when you're going to exit the loop. So you're not just counting numbers, you're waiting for a certain event. So here there's a Boolean variable called keep going. We're going to initialize it to true and print let's get started. And then while keep going is true, and all we have to do is say while keep going. We don't have to say equals true because it is either true or false. So while that's true, we're going to print this is text output, and then we're going to set keep going to the value of input CT input yes no. Do you want to keep going? If they hit yes, then keep going gets the value of true. If they hit no, keep going gets the value of false. So depending on if it's true or false, we come back up here, we check keep going. Every time they hit yes, then keep going is still going to be true, and we're going to keep on doing this loop. Once you hit no, keep going becomes false. This is now false. We drop out of the loop and print we're done. Here's another example. Print powers of 2 less than 1 million. Okay, so we're going to start with I equal 1. While I is less than 1 million, we're going to print I, and then we're going to multiply I by 2. So this would become the powers of 2. Now we could also set I to math.pow of I, comma 2. We could do that as well, so that it's always going up by a power of 2. So there's different ways to do powers, right? We can either multiply by 2 or we can use the math.pow function. Next we'll talk about a do-while loop. So the difference between a while loop and a do-while loop is a while loop might never get executed. If you come up here to a while loop and you look at the condition and for some reason the condition is false, then you would just skip this loop altogether. In a do-while loop, you are guaranteed to go through the code for the loop at least one time. The do comes along, it executes the code, and then it does the test at the end. So there's the difference. In a while, you're doing the test at the beginning and then executing the code and then testing. In a do while, you're going to execute the code and then test. If it's still true, you go back up to the code again. Now notice in a do while, you do have to put a semicolon at the end of the line for the while and the test. So that is very important. No semicolon for the do. We put what we need to execute in brackets, and then you have while the test with a semicolon at the end. So here is an example where you're doing this keep going. Notice on a while, in the while example, we have to initialize keep going to true. And then we print let's get started, and then we test to see if keep going is true or false. In a do while, you don't have to initialize keep going to true. You don't have to have a variable keep going at all. We'll just say let's get started. We say do, we print this is the text output, and then we'll just say while ct.input yes no, and this is going to either be true or false. So we don't have to worry about having a variable come through the first time being set to true. Now, why would you use a while over a do while? Well, do you want to execute the code at least one time? And if you do, then it's preferable to use a do while. If there are times that you might not want to execute this code, then use a while loop. Finally, we have what's called a for loop. A for loop is kind of an easy way to put your while loop in a shorter form. So what happens is, in this example, we have to initialize I to 1, and then we have while I is less than or equal to 10, and then down here we have to increment I by 1. What a for loop does is it takes the initialization, the condition, the test, and the changing of the I, incrementing I, and puts it all on one line. So you would say for, now if I has not already been declared, you can declare it here, or if you do declare it here, it becomes local to this for loop. But if I was already declared, you'd just say I equals 1. But we have int I equals 1 with a semicolon. Then we have the test. So this is the initializing. Then we have the test while I is less than 10. And then a semicolon. And then we do the incrementing. So I plus plus. So the first time through, the for loop looks at the initial value and does the test. If it's true, it goes ahead and executes the code. Then it will do whatever is over here to change the value of I. And then it'll do the test again. If it's still true, it'll execute the code. So instead of doing it in 3 different lines of code, we can do it all in one, but know that the flow of execution is basically the same as in a while loop. We have the initialization that's going to happen once. The test happens every time. The incrementing happens at the end of the loop, and then you go back and test again. So the pattern for a while loop is set the starting value while the value is valid, use the value, get the next, make sure you change the value. But in a for loop, you're doing it all in one line. So if we were to write with placeholders what these loops look like, we would say initialize, while test, process, advance. But in a for loop, it goes for, initialize, test, advance, process. Okay? So even though the advance is here, it doesn't happen until after we process. Here's a couple more examples. Here we can count to 100 by tens. So we can start with I equal 10, I less than equal to 100, I plus equals 10. So we can change this I in any way that we want. And then we print I. So the first time it prints 10. Then it comes up, it increments I to 20. It checks to see if we're still less than 100. If we are, it prints. Then it increments I again until I is greater than 100. Here we can count backwards from 99 by threes. Okay, int I equals 99, that's our initial value, as long as I is greater than 0. And now we're going to subtract 3 from I every time, and we'll print the value. Here we'll draw 20 circles at random positions. For int I equals 1, I less than or equal to 20, I plus plus. So this is just counting. This loop is just counting from 1 to 20. And nothing that happens in the loop has anything to do with the counting. Okay, we're not doing anything with I, we're just using it to count. And then we're going to draw 20 random circles. Okay, here we list something called a break statement. Now, I personally do not like break statements. I think that every loop can be written without a break statement, that you can better ways to make your algorithms. If you can make it so that you exit your loop only with your condition. So rather than a break here, I would maybe use a variable that's a Boolean flag. I would test here to see if that variable, that Boolean flag, is also true, and then maybe set it to false if y is greater than 85, or check that it's false here and set it to true here. So what break does is it literally breaks you out of the brackets that you are currently in. So it would take your flow of control all the way out of this for loop. I don't want to see in my class, I don't want to see anyone using break statements, so don't use them, okay? But what this code is doing basically is counting to 20, getting random numbers, but if y is greater than 85, then we're gonna not draw the circle that we're drawing here. Okay, but again, I would set a variable instead and then also test on that variable. So I could say I less than 20 and flag equals true, or and flag, and then here I would set flag to false or something. Okay, and up here I'd have to set flag to true. Hopefully that makes sense, but don't use break statements in my class. Here's a little bit more on loops. If you only have a single statement inside your for loop or your while loop, well, your while loop you usually wouldn't, but you might. You don't need to have the brackets. It's always nice to have the brackets, but you don't have to have the brackets. You also don't have to put in all three sections of, well, you do sort of have to put in a condition, otherwise you're going to have trouble with your loop, but you can leave pieces of the for loop out. You just put a semicolon to take its place, okay? So here we're not initializing the I. You might have here no condition, but this is going to be a problem because, well, they're using a break, so that'll eventually get you out of this loop. But again, I don't like doing that. Here you have a for loop with nothing in it, and basically you're going to do your circles until you break out. But again, I don't like this. Okay, if you're going to do a for loop, then you should have an initial value, you should have a condition, you should have something that changes in order to eventually make that condition false. Okay, it's much better programming practice. Notice that for code 12, you can write loops that will do your animations, and in your homework assignment I'm going to have you do that, where you put a loop in the start function that's going to have you'll draw some things. But notice that the update function is a loop. It does it for you. So you don't need to put any loops into your update if you're just maybe drawing some items on the screen. It's an automatic loop for you. Okay, update gets called 60 times a second. So keep that in mind when you're using code 12 for doing animations, that update does those animations for you. Okay, now we're going to look at some examples in code 12. There's an example called loops demo, and the loops demo that I have listed in the week that you can look at is a little bit different. I've put pauses in here the one that you have has some things commented out, and then you can comment out different pieces of the code to run it. But what I've done is I've just made it so it will do one piece of code and then it'll pause so that we can see what's happening, and then it'll go on to the next piece of code. So let's look at the first loop here. It's going to print the integers from 1 to 100. So we have num equals 1. While num less than or equal to 100, it'll print a number and it'll increase num. Make sure you do that, otherwise this will never become false. So you have to increase num and then we'll print done. So you can see that that happened here. We printed all the numbers going down from 1 to 100 and then printed done. Okay, let's see here. We'll go to the next one. So the next one, while num equals 1, while num less than or equal to 13, we're going to print num and then we're going to increment num by 2. So what's going to happen here? The first time through, it's going to print 1. Then it's going to increment by 2. So num is now going to have a value of 3. So it's going to come here. It's still less than 13. So then it's going to print 3. And now it'll have a value of 5. So what gets printed over here? 1, 3, 5, 7, 9, 11, 13. 13, it is still less than or equal to 13, but once it prints the 13, num becomes 15, and you can see up here, num is now 15. And then this is false, so we drop out. Okay, what's going to happen on the next one? We're going to count backwards from 10 to 1. So we're going to start num at 10. While num is greater than or equal to 1, we're going to print num and we're going to subtract 1 from num. So is that what happened here? Yes. So we started at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And num is now 0. And so we dropped out of the loop. Okay, the next one is print 10 random numbers from 1 to 100. So we're going to start count at 0, and we're going to go until count is less than 10. So now we're just going to print 10 numbers. So count is just going to be keeping track of how many numbers we're printing. So then we'll print a random number, we'll increment count. Once count is equal to 10, we will finish. So let's see what happens. And resume. And so here are your 10 numbers. And count is now 10. So we are done. Next, print the sum of 1 through 100. So now what we're doing is we're going to say 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100, and then we'll print that sum. So we have an I that's kind of our counter that's keeping track of the 1, the 2, the 3, etc. We're going to have a variable called total, which we need to initialize to 0, because the first time through we need to add that to I to 1, so we need to make sure it gets initialized to 0. So the first time through we have total equals total plus 1, so that's 0 plus 1 is 1. Then I becomes 2. Then total equals 1 plus 2 becomes 3. And we keep going until finally I equals 100. And now we have whatever the total was to then plus 100. Then I equals 101. It is now greater than 100, so we will drop out of our loop, print total, and pause. So our total is 5050. 5050, and you can see that the I is at 101. Here we're going to print the number 1 through 20, but skip 13. Okay, so we're going to set I to 1. We're going to say while I is less than or equal to 20, we're printing 1 through 20, but we want to skip 13. So if I is not equal to 13, we're going to print I. Okay. Notice instead of saying if I equals 13, we do whatever. That's not the way to do the if statement. Is As long as I is not 13, it's going to print everything except for 13. So 11, 12, we skipped 14. We skipped 13 and print 14, 15, 16. So you see, everything got printed except for the 13. Here, we're going to have a little problem. This is going to be an infinite loop because we have while true, enter an amount, calculate a tip, print the tip, and there's nowhere that this ever gets changed, that our condition ever changes. So if I do this and I resume, let's see, 25, we have a tip. 34, we have a tip. 13, we have a tip. It's going to go forever and ever and ever. So now we have a problem because that's what's called an infinite loop. So I'm going to have to stop our code. I'm going to have to comment this out. So that's what I'll do here. I'll say /star, and then here I'll do a // So that piece of code is commented out. I'll have to save it. And then we're going to have to go through and keep resuming till we get to pausing at line 88. Okay. 63. We're going to use the calculator in the correct way. Okay, so we have here Boolean do again equals true, while do again. We're going to set an amount, and then we're going to say, do you want to do it again, yes or no? So now I put in an amount, 23. That's going to ask me if I want to do another one. So I'll say yes, 45. It prints the tip, and then I'll say no, thanks and goodbye, and do again is false, so we got out of our loop. So you have to be careful to make it so that this condition eventually becomes false, or you're in an infinite loop. So then they have all the same examples that we had above, but using a for loop instead. Okay, so up here where we had a while loop to print integers from 1 to 100, remember num equals 1, while num less than or equal to 100, we're going to print, and then we're going to increment num. So in a for loop, you can just say for I equals 1, I less than or equal to 100, I plus plus, print I. It would do the same thing. When we were counting by twos from 1 to 13, we can do that here in a for loop. Here we just say I plus equals 2. Here we were printing 10 random numbers. So we're counting from starting at 1 to 10. We increment I and we print a random number. Okay, here we're printing the sum of 1 through 10. So for I equals 1, I less than 100, less than or equal to 100, I plus plus, we still have to have our total. We're just going to say total plus equals I, and then we can print our total. Here we have our for loop where we're skipping the 13. Okay, here we have our infinite loop. That's not any good. So we don't want to do that. Here we're going to instead start out with do again equals true. That is our initial. Notice we're not starting with a number. We're initializing do again to true, and then we can just say while do again is true right here, and we don't need a third part because we're going to put the do again right here in the CT input. Guess what? We could have taken that CT input yes, no, do you want to do another, and put it right here as part of the for loop, so that at the end of the loop it would come up and it would actually execute this code, and then if do again is true, we'd go back into the loop. And then here is the same examples using a do while. So you would say, you would set printing the integers from 1 to 100, you would have to do this at least once. I equals 500. That's not what we want. That should be I equals 1. and then print I. So that should be I equals 1. Do ct print I plus plus, and we're going to go until while I is less than or equal to 100. But I see an error in here. I see a problem with this code. Does anyone else see the problem? The problem is we're going to come through the first time and print 1, okay? And then we're going to check to see if I is less than or equal to 100, which it will be because it's now 2. But finally, I is going to be 100. We're going to, yeah, this is going to work. So then we come through, we print 100, and then we increment I. So this has to be less than or equal to 100. Okay, here's the same thing with our calculator for the tip. And then here is one with a break, and I don't want you to use a break. Okay, so you can see, you can come in here and you can look at the code and see a lot of examples of while loops, the same examples with a for loop, and the same examples, some of the same examples with a do while. Okay, here's an example. This is like a breakout game, and there's a bunch of code here for creating the game and making it so that you can move the paddle left and right. It's controlling the ball, making sure the ball doesn't go off the screen, bouncing the ball, all of that with making sure that if the ball hits something, it then bounces in another direction. But what I want to show you here is there's a while loop, and this while loop is going to put bricks across the screen. Okay, so here it's saying it's turning left. X left is 0, and while X left is less than 100, we're going to create a brick and then set the line width, put the brick into a group, and then move the brick over by the size of the brick that we just put down, and then increment a number of bricks so we know how many bricks we have. So what happens when we execute this code? If I say enter brick size 20, say, it's going to put the bricks across the screen. They're each size 20, and it knows to put the brick here from 0 to 20. It figures out the center of the brick using the brick size and the left, where the left is currently divided by 2. So it's going to put the brick here, and then it's going to move that X left by the brick size. So now it's going to go from here to here, put the brick in the center there. So let's try it again with a different brick size, 10. We have many more bricks, but this way we can set up the game with however many bricks we want in a row, and that's done in this loop. So just so that you can see that there is more to the game, I can move the paddle. I didn't do that very well, so let's see if I can, if I am able to get the ball, then it hits the bricks. And so that's what the rest of the code is doing. It's calculating, it's making the ball move, and if the ball hits a brick, the brick disappears, and all of that. Okay, so let's stop that one, and I have another one. There's one breakout. Okay, this is the full breakout game. So let's look at it. Here we're doing rows. We have a for loop instead, where we're going to make a bunch of rows of bricks, and there's lines in between, and then we have all the code for deciding if the ball is hitting one of the bricks and all of that. Here's actually making a row of bricks, okay, in a for loop. So this is making one row. We call the make row function, and that is down here that actually draws the bricks all the way across one row. And then we do that for however many rows we're going to have. So in this case, we have 5 rows. If I was to change 5, the code would still work, and it would just have different numbers of rows. But since we've broken it up into functions, it makes it easy to modify if we want. So again, the code, this is a pretty nice game. So let's see, I can play. Now it has to keep track of each of the different rows. If the ball hits the brick, it disappears. So you're welcome to check this game out, this code out. I also have it listed for the week, in the week, and it's just another example of using a for loop in your code. Finally, I want to talk for a minute about your programming assignment, Program 8. In Program 8, you're going to start with some code. There's actually not a whole lot of code. What there is a whole bunch of comments that you are then going to write the code for. And it's just doing a whole bunch of loops, while loops, for loops, and do while loops. When you're doing it, you're going to be printing meaning printing to the screen. I want all of the printing done inside the body of the loops. You shouldn't have any if-else statements anywhere in the code, and everything needs to be done using the logic of loops, and there should not be any break statements. So this is what it's going to look like. You're going to have Program 8 here. You have a couple of examples. So it'll say, use a while loop to print the integers from 1 to 10. And it's going to print example 1, and then you're going to have this while loop that prints the integers from 1 to 10. Notice it prints them out in a line because you have CT print, and then we're adding after n, we're adding a blank space so that they're not all completely right on top of each other. Then use a for loop to print even integers from 2 to 20, and this is how you would do that. And then what happens is I give you a whole bunch of comments. So use a while loop to print the integers from 10 to 19. Use a while loop to count backwards from 5 to 1. So you're going to do all of that with a while loop. Then you're going to do all those same things with for loop. Then you're going to do it again with a do while loop. So you might have to be careful. And then you'll have a little bit of graphics that can make some loops to draw some graphics on the screen. You won't use the update function at all. You shouldn't have to. So you'll be doing everything in loops in the start function. So pretty straightforward, just gives you a lot of practice writing loops before we get into more complicated code. So have a great week. Remember, you can email me questions. You can come to my office hours. Hopefully everybody's doing well, and I'll talk to you next week.